vision and pay me. It's never to sway me. Indigenous, maybe we winning this crazy. Opportunity, your opportunity, your opportunity, your opportunity. This your opportunity, your opportunity.
Welcome to EDI on the Street, the show where we discuss all things EDI and supply chain.
Thanks for having me back.
Yeah, of course. So I'm looking at a pretty massive stack of sources we pulled together for today's discussion.
Oh yeah, it's quite a stack.
Right. We've got our own internal implementation case studies from right here at GraceBlood.
And, several highly technical payload serialization benchmarks too.
Exactly. And the underlying theme across all these documents is just, it's this massive systemic tension between trust and speed.
Yeah, that's a really good way to put it. Trust versus speed.
I mean, we have enterprise teams trying to force real-time API performance out of, 40-year-old batch protocols.
Mm-hmm. And on the flip side, you have these startup vendors trying to run multi-billion-dollar logistics networks on basically schemaless web frameworks.
Which is just creating total operational chaos. So our mission today is to, move completely past the polished vendor pitches.
Oh, please. We definitely need to do that.
Right. We are going to examine the actual mechanical behavior of 4 foundational integration formats.
X12, XML, JSON, and flat files.
Yes. Because if you're prepping for an IT integration meeting, or you're just trying to understand why your supply chain data keeps breaking, you need to look at how their memory handling and validation logic actually dictate network architecture.
Which is a conversation that is, frankly, long overdue.
Yeah.
Oh, absolutely. Because, as we see every day here at GraceBlood, enterprise architects are often so focused on the transport layer.
Like just how the data gets from point A to point B.
Exactly. They get hyper-focused on the transport, and they completely ignore the payload structure. They treat the actual format of the data as an afterthought.
I see that constantly in our GraceBlood integration reports. The prevailing attitude is essentially this data is data myth.
Oh, the data is data myth. It is everywhere.
It really is. There's this incredibly pervasive assumption that if a system can ingest a payload, the specific serialization format is just irrelevant plumbing.
Right, because it all moves data, so it must be interchangeable.
Yeah, but thinking these formats are interchangeable is like saying a steel shipping container, a Ziploc bag, and a loose cardboard box are all exactly the same because they all hold things.
That is a perfect analogy.
Yeah.
Because sure, they hold things. But applying that logic to enterprise architecture is like receiving a highly complex, precision-engineered engine part without the schematic.
Okay, I like that. Expand on that a bit.
Well, the syntax might be valid, right? The part physically mounts onto the engine block perfectly.
Right. It fits.
It fits. But because it lacks the surrounding contextual metadata, you might not realize it's calibrated for a completely different voltage.
Oh, wow. And it doesn't fail right away, does it? The engine actually starts.
Exactly. The engine starts. You think the integration was a total success.
But then, 3 days later, that subtle voltage mismatch, or, in our world, a data type mismatch where a string was processed as an integer, it quietly burns out the alternator.
And the operational fallout from that is massive. Plus, tracing it back to the data format is an absolute nightmare.
I bet. I was looking at a nightmare scenario from the source material where one team thinks an integration is working perfectly, but another team is seeing completely scrambled or missing data downstream.
Yeah, that happens all the time. And that's exactly why the data myth is so dangerous. The container dictates the validation logic,
Yeah.
It dictates the CPU load required to parse it, and most importantly, it dictates the exact moment the system will fail if something is wrong.
So the structure is the main defining factor of success here.
Absolutely.
Right.
Formats dictate whether an error is caught at the perimeter gateway or whether it's allowed to just, poison the core database.
Well, let's follow that thread then. If the structure of the data dictates where and how a system fails, we should probably start by looking at the most rigid, structured container in the shipping yard.
You're talking about the absolute heavyweight gatekeeper of B2B integration.
Yes, X12.
The unforgiving backbone of the global supply chain.
Unforgiving is the right word. For any massive retail or manufacturing operation, X12 is completely non-negotiable.
Oh, yeah. You want to drop shipments for the big box stores? You're building 850s for purchase orders? You're building 810s for invoices? You have to.
But let me push back a little on the prevailing narrative around X12.
Okay, go for it.
In the 2026 integration report, there's a pretty heavy critique of its rigidity. I mean, It's a standard that originated in 1979.
True.
It was built for dial-up value-added networks, not real-time cloud computing.
That's so true.
So if the mapping process is notoriously brutal-like, it requires massive out-of-band coordination just to set up a trading partner, why haven't these massive organizations deprecated it? Why do the biggest companies in the world still trust it blindly?
Well, it's because that notorious rigidity is precisely what makes it mathematically scalable.
Mathematically scalable, how so?
Look at how X12 is actually structured. There is virtually zero metadata sent with the payload. It relies entirely on positional mapping and segment delimiters.
Right, like asterisks and tildes.
Yes. The file doesn't explicitly tell you, hey, this next string of characters is the invoice date.
It just sends a string of characters in a highly specific segment.
Exactly, like the DTM segment. And it just fully expects the receiving system to consult its strict internal dictionary to understand what that string means.
Which means the payload is incredibly dense, right? It's super bandwidth efficient. But the trade-off is that the receiver has to possess the exact same blueprint.
Precisely. The mapping logic is totally decoupled from the payload itself.
Which makes onboarding painful.
Oh, it's brutal. Every new partner requires extensive mapping, testing, and validation. It's an intense, grueling process of alignment.
But there's an operational advantage once it's set up.
A massive advantage at scale, the perimeter defense. Because the parsing engine checks the incoming document against that rigid, predetermined syntax down to the exact placement of a single asterisk, any anomaly throws a 997 functional acknowledgement rejection instantly.
It just bounces the bad data at the gate. I was reading through some error logs in one of our GraceBlood case studies, and the sheer hostility of X12 error handling is kind of fascinating. It does not gracefully degrade at all. If an N1 segment like the name and address loop is missing a crucial qualifier, the parser doesn't even try to guess the context.
No, it halts. The truck stops at the gate.
And to a business analyst, that looks like a bug, because they just want the order to flow through and get processed.
Sure, the business side hates it when things stop. But to a database administrator, that strict failure is a vital feature.
Because it prevents cascading data corruption deep inside the ERP.
Exactly. That is the core architecture of trust. You have to remember, X12 was designed in an era where compute power was incredibly expensive and network bandwidth was virtually non-existent.
Right. They had to be efficient.
The standard had to enforce absolute trust before a single byte of data was committed to a mainframe. The friction you experience during setup is just the premium you pay for zero ambiguity during execution.
Okay, so X12 gives you massive scale and reliability, but at the total cost of agility. You get structural integrity, but it turns like a battleship.
Yeah, that's a fair assessment.
But as the market moved into the late 90s and early 2000s, supply chains really started demanding real-time visibility.
Right, the batch processing nature of X12 just couldn't keep up with the demand for immediate, queryable state changes.
And the industry needed a format that humans could actually read, right? Something they could debug on the fly, and that applications could dynamically route.
Which brings us to the great compromise.
XML.
Yes. Extensible markup language. The heavyweight middle ground.
The shift to self-describing data.
Exactly. The core innovation here is that XML embeds the metadata directly into the payload.
So instead of relying on an external dictionary to know what, position 5 and segment 3 means, you wrap the data in explicit tags.
Right. You physically transmit a purchase order tag or quantity tag right over the wire.
I can see how valuable that must be for cross-team collaboration. Like, non-EDI teams can actually look at the data and understand what they are seeing. It must make debugging far easier.
Oh, it solved the fundamental opacity problem of X12 overnight. From an operations perspective, bridging legacy systems with early enterprise service buses required middleware that could actually read and route payloads based on their contents.
And XML allowed for those complex hierarchical tree structures.
Oh, yes. But what's the catch?
Well, looking at the payload parsing benchmarks from the GraceBlood technical review, the term human readable hides
a huge penalty. Performance.
Right, because you are transmitting the metadata with every single transaction, the file sizes just bloat exponentially.
The bandwidth penalty is severe. XML gets incredibly heavy very fast. But honestly, the compute penalty is actually worse.
Really? Worse than the bandwidth?
Oh, yeah. When a system ingests an XML document, it doesn't just read it line by line. Most standard XML parsers build a document object, model a DOM tree in the system's memory.
Oh, wow. So if you receive a massive catalog update in XML,
the parser has to allocate memory for every single parent node, every child node, and every attribute before the application can even begin to process the data. It just devours RAM.
I was looking at a specific benchmark comparing a 5 megabyte X12 file to its XML equivalent. The XML translation swelled to over 25 megabytes.
Yeah, well, 5 times increase is pretty standard.
It's like taking a tightly packed pallet of goods, unwrapping every individual item, placing it in its own custom-labeled box, surrounding it with structural supports, and then putting it all back on the truck.
That's exactly what it's like. The clarity is perfect, but you completely exhaust your network throughput and your server's memory just trying to load the tree. When you're processing thousands of supply chain transactions, that extra weight bogs down systems significantly.
Which is why enterprise architecture developed SX parsers, right? Simple API for XML to read the stream sequentially without building the full tree.
Right. But even then, the sheer verbosity of XML remained a major bottleneck. However, we really cannot dismiss its governance capabilities.
You're talking about XML schemas, XSDs.
Yes, XML introduced XSDs, and this is where XML bridges the gap between the strictness of X12 and the flexibility of the modern web.
Let's expand on XSDs for a second. How do they actually enforce structure?
Well, an XSD acts as a highly rigorous compiled contract. It doesn't just say, hey, expect a tag called price. It explicitly dictates that the price tag must contain a decimal value, it must be greater than 0, and it cannot exceed 5 digits.
So the parser validates the incoming XML against this compiled schema in memory safely before the application layer ever touches the data.
Exactly. It enforces data typing and structural hierarchy dynamically. It serves as excellent middleware, especially when you're bridging legacy EDI setups with newer enterprise systems.
It provides the strict governance of X12, but with the dynamic, self-describing flexibility needed for cross-team collaboration.
Which explains why the vast majority of legacy B2B APIs, like specifically SOP web services, were entirely built on XML.
But as you pointed out, the compute overhead eventually broke the model.
It did. When mobile architecture and highly distributed microservices became the standard, the network simply couldn't tolerate the payload bloat or the memory consumption of XML DOM parsing anymore.
If XML is too heavy and slow for lightning-fast modern web traffic, what are developers reaching for today when speed is the absolute top priority?
They reach for JSON.
JavaScript object notation, the modern standard that developers absolutely expect today.
Exactly. If X12 is the strict gatekeeper and XML is the heavily regulated translator, JSON is the Autobahn. It is the undisputed standard for modern RESTful APIs.
And it's so clean and lightweight, it fundamentally altered the serialization paradigm, didn't it?
It completely changed the game. It abandoned the heavy document tree structure of XML and instead modeled the data exactly how modern programming languages store data in memory.
The benchmarks highlight this specifically. JSON is built on simple arrays and key value pairs, things like, status shipped.
Right. And because that structure perfectly mirrors JavaScript objects, Python dictionaries, and Ruby hashes, the CPU doesn't have to go through a complex translation layer to build a DOM tree.
It just maps directly to the application logic?
Directly. It directly deserializes the payload straight into the application's memory. The processing speed is just staggering.
And it strips away all those heavy closing tags of XML, which dramatically reduces the payload size over the wire.
From a developer experience standpoint, it is totally frictionless.
Yeah.
You can iterate an API endpoint in an afternoon because you don't have to compile complex XSD schemas or configure rigid parsing dictionaries.
You just pass the JSON object and the application ingests it.
Exactly. This translates to incredibly fast implementations and rapid iterations.
There's a catch?
There is a massive hidden risk.
Right. In the 2026 report, they flagged this frictionless developer experience as an illusion built on deferred technical debt. JSON achieves its incredible speed by entirely abandoning native governance.
There is a total lack of strict enforcement. There is no built-in, widely adopted schema enforcement like XML's XSD.
It's like speaking in casual slang. It's a really fast way to communicate if both systems totally understand the shorthand, but it's a disaster if they interpret a word differently.
That is a perfect analogy. JSON is dynamically typed, meaning the data type is inferred by the syntax, and it is incredibly loose with those inferences. Let's look at the engine part metaphor again. Two different vendor systems can technically send perfectly valid JSON payloads. The brackets match, the syntax is clean, but they can structure the data completely differently.
Give me an example of how that breaks down.
Okay, so one system might send a SKU quantity as an integer, simply the number 10. The receiving system's API expects an integer, so everything works perfectly.
Right.
But then the vendor updates their software, and suddenly they start sending the quantity as a string. The number 10, but wrapped in quotes. 10.
In X12 environment, that type mismatch triggers an immediate sequence failure at the gateway, right?
Instantly. And in an XML environment, the XSD schema catches the string, throws an exception, and rejects the payload safely.
But in a standard JSON REST API?
The gateway parser sees a valid string, says syntax checks out, and returns an HTTP 200 OK success code. The payload sails right through the perimeter.
Oh, wow. It doesn't fail immediately at the door?
No, JSON's inconsistencies creep in quietly. They don't trigger immediate system failures.
And the downstream application logic, like maybe the warehouse allocation algorithm, tries to run mathematical calculations on a text string.
Exactly. And the application either throws a fatal runtime exception deep within the database layer, or worse, the underlying language attempts to coerce the type.
Wait, coerce the type? What does that mean?
In some JavaScript environments, adding the integer 10 to the string 10 results in the string 1010.
Oh my God.
Yeah. Suddenly your warehouse system thinks it needs to allocate 1,010 units instead of 20.
That is the terror of silent failure. They show up later as baffling data issues.
And it extends beyond basic integers, too. JSON has no native date type.
Wait, really? None?
None. Every single timestamp is transmitted as a string. If your trading partner decides to switch from an ISO 8601 formatted date string to a Unix epoch timestamp, JSON doesn't care. It validates the string.
So it requires intense governance that teams often underestimate.
Highly underestimate. It is up to your internal developers to write thousands of lines of custom validation code to catch those discrepancies.
So you are trading structural safety for operational speed. JSON forces the burden of data integrity out of the transport layer and pushes it squarely onto the shoulders of your internal software engineering team.
Which is why modern enterprise architecture has to treat JSON APIs with intense scrutiny. It is incredibly fast for internal microservices where you control both the sender and the receiver.
Like, for example, using a modern API gateway can ingest JSON at lightning speed and route it perfectly because it's built for that environment.
Exactly. Amazing for rapid webhook routing. But exposing JSON to external supply chain partners requires layers of synthetic validation.
If you don't build robust custom guardrails, you are inviting corrupted data directly into your core systems.
Absolutely.
Well, if JSON is risky because of its loose rules, our final format is essentially walking a tightrope without a net.
Oh, here we go.
We need to talk about the terrifying persistence of flat files.
CSVs and fixed width text files.
Right. They seem wonderfully simple. But the data from GraceBlood shows that despite all the advancements in APIs and EDI, a staggering volume of global commerce still runs on simple, comma-separated values.
It is the ultimate illusion of simplicity, and they are incredibly dangerous.
Why do people still use them so much if they're so dangerous?
Because anyone can open a CSV in Excel. Business analysts look at it and assume it is a safe, universal format. But structurally, flat files do not enforce anything.
Yeah.
They are by far the most dangerous integration method in existence.
Because they rely entirely on position or a simple delimiter, like a comma.
Right. There is absolutely zero built-in validation to catch errors before they process. A flat file has no headers that the system can inherently verify, no nested hierarchy, and absolutely zero data typing.
It's just raw text separated by arbitrary symbols.
Exactly. I was reading the operational horror story from the source material regarding legacy mainframe persistence. Fixed-width files rely entirely on rigid character counts.
Right, so if your item description is allotted 20 characters,
and your supplier suddenly sends a 21-character description.
that single extra character pushes every subsequent piece of data in the entire file out of alignment by one position.
Yes. The price becomes the quantity, the date becomes the warehouse code. If just one single column shifts, everything downstream breaks.
And CSVs rely on delimiter logic, which is equally fragile.
Oh, CSVs are a nightmare.
Okay.
If an end user is manually typing an invoice description and accidentally includes a comma like widget blue.
The naive parser treats that comma as a column break.
Yes. The system ingests the word blue into the pricing column.
And because there is no validation, these errors can go unnoticed for days. The system cannot bounce the file at the gateway. It just blindly ingests the misaligned columns.
The errors don't trigger server alarms or HTTP 500 codes. They bypass the IT department entirely.
Which emphasizes the real-world fallout here. You only find out there's a problem when finance balls complaining that invoices don't match.
Or the warehouse floor staring at the wrong shipments. You have a forklift driver staring at a pallet they can't scan. Or $1 million invoice discrepancy. Flat files only work in highly simple, tightly controlled environments.
Now, to be fair to the modern data engineers listening to this, nobody is just dumping raw CSVs directly into a production database anymore, right?
Well, mostly.
The current landscape uses advanced ELT extract, load, transform pipelines to handle these flat files. You drop the CSV into an isolated quarantine bucket, and you run advanced regex patterns and machine learning-driven schema inference tools to clean, validate, and normalize the data before it ever touches an ERP.
True. But think about what you just said. Think about the sheer amount of compute power, architectural complexity, and engineering time you have to invest just to make a flat file safe to handle.
Oh, I see. You are building an entire synthetic ecosystem just to compensate for the fact that the format itself is fundamentally devoid of structure.
Exactly. You're trying to bolt structure onto something that inherently rejects it.
Okay, so having dissected the mechanical realities of all four formats, I want to put them head to head.
Let's trace a hybrid transaction lifecycle based on an architecture model we see frequently at GraceBlood.
Let's run the gauntlet. Let's walk through a single purchase order, or actually, let's look at the flow of an advanced ship notice, an 856 entering a business.
Perfect, an ASN.
A major logistics provider initiates the process. They drop the strict, densely packed X12 856 over an AS2 connection.
So your perimeter gateway ingests it. The X12 parser checks the positional syntax against the strict dictionary.
Strictly formatted and heavily validated before it even gets processed. It is verified instantly, bouncing any anomalies before they penetrate the firewall.
Right. But once validated, the gateway cannot pass that rigid X12 directly to your modern cloud ERP. So the middleware layer steps in.
It translates that payload into a heavily structured XML document object model.
Exactly. It inflates the payload size, but it attaches explicit namespaces and XSD validation rules. Structured and readable, validated safely through a schema, ensuring the legacy data maps cleanly to the required enterprise fields.
And then the enterprise service bus routes that XML to your internal inventory management system.
But the architecture doesn't stop there.
Right, because your third-party warehouse management system, which operates entirely in the cloud, needs to know about this incoming shipment.
So your integration layer takes that heavy XML, strips away all the markup tags and DOM overhead, and serializes it into a sleek, lightweight JSON payload.
Fast and flexible.
It fires that JSON out via a webhook. Like we mentioned earlier, it hits an API gateway, routes it to the warehouse system, and updates the dashboard in milliseconds.
But you are entirely dependent on your own internal system to validate it at that stage.
Exactly. And finally, to close the loop, your legacy finance mainframe, which has been running since, 1998, needs a record of the transaction for end-of-day reconciliation.
And it doesn't speak JSON or XML, and it isn't configured for the specific X12 loop.
So the middleware runs a final translation, generating a strict fixed-width flat file, and drops it onto an SFTP server,
where the mainframe runs a nightly batch job to ingest it, and you are essentially crossing your fingers and hoping nothing shifted.
Hoping the character limits haven't shifted, exactly.
So if you're building a modern supply chain, which one are you supposed to pick?
That's the trick. Most companies don't choose just one. They are dealing with all of them simultaneously.
Because you have a retail partner demanding X12, an internal legacy system running on flat files, an API integration utilizing JSON, and middleware translating it all with XML.
That is the reality of the gauntlet. The challenge isn't choosing a format. It's managing the complexity. The format is just the surface layer.
So your integration strategy is what actually dictates success.
Yes, that is the main thesis. If your translation layer is brittle, a single type coercion error in a JSON payload or a misplaced segment in an X12 document will halt your operations. A resilient architecture anticipates the structural flaws of every container and actively mitigates them before the data hits the database.
It is about engineering for failure at the correct layer of the stack. You want the failure to happen loud and early, not silently and late.
Loud and early is always better.
So, synthesizing everything we've talked about today, every format has a distinct purpose and a really painful trade-off.
XML gives reliability. XML offers structured flexibility. JSON provides speed. And flat files offer,
well, risky simplicity.
Risky simplicity is putting it nicely. The goal isn't to eliminate formats, but to integrate them properly so teams avoid fragmentation and data remains consistent. Bad data flow equals operational nightmares. Good integration is the cure.
I love that. Which brings me to a final sort of provocative thought for everyone examining their own architecture.
Let's hear it.
We have established that modern businesses are permanently forced to juggle all four of these formats, right?
Right.
So will the future of the supply chain belong to the company with the best native data format? Or will it belong to the company that builds the most invisible, seamless translation layer between them all?
Oh, that's interesting, especially as machine learning models become deeply embedded in integration middleware.
Exactly. Platforms that can dynamically infer intent, autocorrect type mismatches on the fly, and heal broken XML schemas without human intervention.
When systems start repairing their own data structures dynamically, the definition of trust is going to fundamentally change.
Will the strict, unforgiving rigidity of X12 eventually become obsolete? Or will the sheer volume of global automated trading demand and even stricter, mathematically enforced protocol to prevent AI-driven hallucinations from corrupting the core database?
That is the horizon we are building toward.
A horizon where the container might just learn how to unpack itself.
I wouldn't bet against it.
Well, thank you for tuning in to EDI on the Street. Be sure to subscribe and share the episode with your team.
And if you are currently drowning in multiple data formats, just know you are not alone. It's the reality of modern integration.
Absolutely. We hope this gave you the ammunition you need to look past the data is data myth and critically evaluate the structural integrity of your own integration layers. Take these insights back to your architecture planning meetings, and remember, when you are dealing with global supply chains, speed is irrelevant if you can't trust the payload. We will catch you next time.
Indigenous, maybe we winning this crazy. Your opportunity, your opportunity.